Okay. So again, unless something weird happens, like, you know, my internet goes down or I get sick or something like that, I'm okay time-wise. In fact, I've budgeted where if I spend 2 days per section, I still should be okay. So 4-9 or 9, I could even afford to go back another day. So 2 days, 2 days, 2 days. If we get to 5-3 by Thanksgiving, we're in very good shape. Even if I only get to part of 5-3, we're still okay because then we only have a couple of sections and we have 2 weeks left. Okay. So we'll see about this date for the last exam. I might move it, but I might not. We'll see how it goes. Okay, again, our final exam is Wednesday, December 16th. So that's what, less than a month already. Okay, 11:10 to 1:40 for the final exam. Okay, so we're doing antiderivatives. Okay, so I was going to do a bunch more antiderivatives, and then I wasn't going to start 5.1 yet. So if I finish, quote unquote, early, then I'll let you ask questions. If you want me to do some other problems from 4.9, we could do that. Okay, and if not, then that'll just be it for today. Okay, so we're doing more antiderivatives, please. Okay, I know some of you said something in the chat, but I can't see it unless it's to Prasanna. And Prasanna, if you want to answer it, you may. Thank you ahead of time for that. Okay, so we're doing antiderivatives. Again, we're using the integral sign. The book doesn't use the integral sign, but I'm going to use it. Okay, so we left off somewhere around here. Okay, so for all these problems, it says find the most general antiderivative. I change it to an integral symbol, dx or dt or whatever the letter happens to be. Okay, so I'm going to show you some problems from 25 on. Okay, so find f. Now I see some problems where they give us f double prime or even f triple prime. Okay, and then they might give us some initial condition, so-called, so we can find the c, like f of 4 is 25, and so on. Okay, so here we go. Put down the book because the book is heavy. All right, 25. F double prime is 20x cubed minus 12x squared plus 6x. Okay, so notice we're going backwards from what we did before in the course, right? A lot of our course, we said, here's f, find the first derivative, find the second derivative, right? Now we're going backwards. This is the second derivative. Go back and find the original function or functions properly. Okay. So this is f double prime. What was the original f? Okay. Or this is the answer to a second derivative question. What was the original question? Right? So we start off before, here's f of x. Okay, take the first derivative, take the second derivative. Now we're going the other way. Here's the double prime. What was the original function? All right, so I integrate once to find f prime. And notice even this is a little bit weird, right? Because all throughout the majority of the course up to now, when we see the symbol f prime, right? We say, oh, I'm taking a derivative. Not now, we're taking an antiderivative, okay? By analogy, it's kind of like you're either going up or down the elevator. Before we were taking a function, first derivative, second derivative, it's like you're going down. Now we're going back up. We're starting at the second derivative level. How can I get back up to the original f? Okay, so f prime is the integral of 20x cubed minus 12x squared plus 6x dx. Okay, power rule. Leave the coefficient alone, x to the fourth over 4. Minus 12, leave the coefficient alone. Power root, x cubed over 3. Plus 6, power root, x squared over 2. Plus c1. Why the c1? Because I have to integrate again, and there'll be another constant. I should not just put c. Because if I put c, then the other one I put c, you're implying mathematically that the two c's have to be the same. They do not have to be the same. So one way you can do it is call one of them c1, the other is c2, or just give them different letters like c and d or something like that. Okay, this comes up to 5x to the fourth minus 4x cubed plus 3x squared plus c1. Okay, now there's a very easy built-in way to double check all your integral problems. How can you check that this is correct? Take the derivative, right? How do you check an antiderivative? Take the derivative. right? So you say, I wonder if I did this correctly. Take the derivative. What's the derivative of that? 20x cubed. What's the derivative of negative 4x cubed? Negative 12x squared. What's the derivative of 3x squared? 6x. What's the derivative of C1? 0. So we're good. Okay, so I do another antiderivative, a second antiderivative, if you were, or second integral. Just like before we did a derivative, second derivative, and you can do more, third derivative, fourth derivative. Now we're going backwards, right? Here's the second derivative. Integrate once, you're back up the elevator, so to speak. You're back up to the f prime level. Integrate again, and you're back up to f. Okay, so it's like you go up or down the elevator, so to speak. Okay, so integrate this thing. So power rule again. 5 x to the 5th over 5. Remember the power rule? You bump up the exponent by 1 and divide by the new exponent. Minus 4 x to the 4th over 4 plus 3 x cubed over 3. What's the integral of C1? C1x. The derivative of a constant is the constant times x, or t, or whatever letter you happen to be using, plus a constant, plus C2. And notice very conveniently, cancel, cancel, cancel. So final answer, x to the 5th minus x to the 4th plus x cubed plus C1x plus C2. Okay. Give me any number you want for C1, any number we want for C2. So all of these functions, plural, you have infinitely many of them. Pick any number you want for C1, any number you want for C2. All of these functions have the property that the second derivative is this. And it's very easy to double check. If you were to differentiate, you're basically just tracing backwards, just kind of going backwards to what you had. We can do that. Okay, remember this is an infinite class of functions. Give me any number you want for C1, C2. So maybe this is 10, this is negative 13, or this is, pi, and this is e, or this is 1 million, and this is 316.521414828, or whatever. Okay, all of these functions have this as a second derivative. Okay, let's try it. What's the first derivative? Well, 5x to the 4th minus 4x cubed plus 3x squared plus C1, right? So that definitely checks. What is the second derivative? Then I differentiate this. So the derivative of this would be 20x cubed. There it is. Derivative of that is minus 12x squared. There it is. Derivative of that is 6x. There it is. And derivative of C1 is 0. So we've proven that the derivative of any of these functions, where'd it go? Derivative of any of these functions is indeed this. So it works. So again, please notice the language. When you have a function, you would say the derivative, but there are many antiderivatives. There's actually infinitely many antiderivatives, but they differ by a constant. Okay, so when you get to the second derivative level, and you have to go back to the original, we're going to use C1 and C2. Or you could pick, C and D or something like that. Okay, here's 29. F triple prime is 12 plus sine of t. So we're starting at the triple prime level. Here's the third derivative. What was the original function? Okay. All right, so the previous one I did a C1 and C2. Can you guess what's going to happen here? C1, C2, C3. 3 levels. Okay, so this is the third derivative. What was the original function? So f double prime equals the integral of 12 plus sine t dt. Yeah, I know this looks even funny because normally when you see second derivative, right? Up to now, you say second derivative. Oh, we had an original function. We must have taken one derivative and we took another derivative. But not in this case. We're actually taking an antiderivative because we're starting off with the third derivative. So I take the first antiderivative, the first integral, and now I've gone back up one level. I'm up at the double prime level of the elevator, so to speak. Okay, integral of 12, 12t. Okay, integral of the sine. Careful, not the derivative of the sign. We're not asking for the derivative of the sign, which is cosine. We're asking for the antiderivative of the sign. What function is there whose derivative comes out to be sine? Negative cosine t. Is that right? So yeah, now you have to be careful. Am I going the direction of derivative or antiderivative? If I'm doing antiderivative, integral, the integral of the sign is negative cosine. Because the derivative of negative cosine is positive sine. Is that right? Plus C1. Double check your answer. How do you double check? Take the derivative, right? If this is indeed correct, if this f double prime is one level up from f triple prime, so to speak, that means the derivative of this should be this, right? What's the derivative of 12t? 12. What's the derivative of negative cosine t? Positive sine t. And what's the derivative of any constant? 0. So it works. Okay, so that's f double prime. Now I'm going to integrate again. Again, what's integrate? Integrate means anti-differentiate. So for us in calculus, integrate means anti-differentiate. Yes, we know integrate, integration, they have their meanings in regular, ordinary English. But for us, integrate, integration means anti-differentiate. Okay, so f prime is the second antiderivative. So before we had second derivative, now we have second antiderivative. So integrate, integral of 12t, 12t squared over 2. I already gave away the answer, but what's the integral of negative cosine? Negative sine. Because the derivative of negative sine is negative cosine. Integral of C1, C1t. Plus a constant, C2. Again, you must put C1 and C2 or different letters. You can't just put a C here or a C here because mathematically that implies these C's have to be the same. They do not have to be the same. So this C can be, 47. This one can be negative 1,000,000. That's allowed. And clean it up to be this. Okay. Double check. Okay. So if you question yourself, say, I wonder if I did this right. Take the derivative of this, right? What's the derivative of this? 12t. What's the derivative of negative sine t, negative cosine t? What's the derivative of C1 times t? C1. What's the derivative of C2? 0. It works. Okay, so I've done one integral, two integrals. So finally, I'm at the level of f, right? 3 floors up, so to speak. I'm 3 floors down with f triple prime. So I go up the elevator once, I'm at f double prime. Go up the elevator again, so to speak. I'm at f prime. Go up the elevator one more time. I'm finally at the level of f. So before it was always derivative, right? It's kind of like you're going down, down, down. Now we're kind of going back up, up, up. Okay, so f of t is the integral of this. Notice I did 3 antiderivatives, which is the opposite of taking 3 derivatives. Okay, so what's the integral of 6t squared? 6t cubed over 3. Antiderivative of negative sine, positive cosine, because the derivative of cosine is negative sine, correct? Integral of C1t, C1t squared over 2. Integral of C2, C2 times t, plus a constant, C3. Okay, so clean it up. 2t cubed plus cosine t plus 1/2 C1t squared plus C2t plus C3. Okay, I'm actually going to accept that answer, but I believe the back of the book just has this as C1, and I might be barking up the wrong tree for this one. And so some of you might not understand this concept, but this pen doesn't work. Okay. 1/2 C, I can get any real number with that. 1/2 or 1/2 C1. Okay. I can generate all the real numbers with 1/2 C1. So if I can generate all the real numbers, I might as well just leave it as C1. It really means you can have any real number coefficient in front of t squared. Okay. So 1/2 C1, I can get all the real numbers. You might as well just call it C1. Okay. So this is actually the best answer, but I'll accept that. Okay. Okay, now just like yesterday, you have some problems here where you can find out the values of C. So 41, f double prime is blah, blah, blah. F of 0 equals 3, f prime of 0 equals 4. So I can use this information to find out C1 and C2. So my final answer will not have C1 or C2. It'll just be one function, hopefully. Okay, so this is the second derivative. Okay, caution, can notice the terminology. We're not asking for the second derivative of sine theta plus cosine theta. We're saying this is the second derivative. This is the answer to something by which I took two derivatives. What was the original function? You see. Okay. All right. This is the second derivative. What was the original function? Okay, so they give me this. So f prime is the integral of sine theta cosine theta. Again, please notice this is kind of different than what we're used to, right? What we're used to is f prime. Oh, I took a derivative. Actually, no. Here you took an antiderivative because we started off at the double prime level, down here, so to speak. So I go up the elevator and I'm at the f prime level. Not because I took a derivative, it's because I took an antiderivative because I started off at the double prime level. So I integrate sine theta plus cosine theta. Okay, so, and yeah, this kind of messes with your brain a little bit because we're going backwards. What was the integral of the sine again? Caution, not the derivative, antiderivative of sine, negative cosine. And what's the integral of the cosine? Sine plus C1. Okay. Double check. What's the derivative of this? What's the derivative of negative cosine? Positive sine. And the derivative of sine is cosine. And the derivative of C1 is 0. So this works. How do I find C1? I use this information. F prime of 0 is 4. Okay, I'm at the level of F prime. So when I plug in 0 for theta, the result is 4. The y value is the word. So 4 is equal to, plug in 0 here, plug in 0 here. Negative cosine 0 plus sine of, that should be 0 actually. I got to the next level. Sine of 0 plus C1. Okay, cosine of 0 is 1. Sine of 0 is 0 plus C1. Add 1, so C1 is 5. So f prime of 0 I can now write as negative cosine theta plus sine theta plus C1, which I found out is now 5. So this function now has a property that, let's see, when you plug in 0, you get 4, right? Put a 0 here, a 0 here. Negative 1 plus 0 plus 5 is 4. And the derivative of this is this, right? Check. What's the derivative of negative cosine? Sine. What's the derivative of sine? Cosine. What's the derivative of 5? 0. So we're good. Now I want f of theta. So I integrate one more time. Second antiderivative. We did a second derivative. We're now going to do second antiderivative. So I integrate negative cosine theta plus sine theta plus 5 d theta. By the way, some of you may have already caught this, even though I never mention it. Okay, for an integral problem, once you add or subtract something, you're supposed to put parentheses. Okay, so technically, it's not correct if I leave out the parentheses. If I just put negative cosine theta plus sine theta plus 5 d theta, then by order of operations, the d theta would only apply to the 5 and not everything else. But you want the whole expression. Okay, so once you have more than one term, when you add or subtract stuff, put it in parentheses. Okay. So integral of negative cosine, negative sine. Integral of sine, negative cosine theta. Derivative, antiderivative of 5 d theta is 5 theta plus C2. Okay, now use this. f of 0 is 3. So when I plug in 0 for theta, the result is 3. So 3 is negative sine 0 minus cosine 0 plus 5 times 0 plus C2. Sine of 0 is 0. Cosine of 0 is 1, negative 1. 5 times 0 is 0. Okay, so that's C2. Add 1 to both sides. C2 is equal to 4. Okay, so I got it. So my final answer is, just put a 4 there. F of theta is negative sine of theta minus cosine theta plus 5 theta plus 4. So that is the one and only one function. No c's involved. Okay, so this one function has 3 properties. Property number 1, the second derivative comes out to be that. You can verify that. Property 2, for the derivative, if I plug in 0, I get 4. Okay, we did that. But if you take the derivative, plug in 0, you get 4. And property number 3, if I plug in 0 to the original, I would get 3. So I put a 0 here and a 0 here and a 0 here, you get 3. Okay. That's what's going on. Okay, then 47, they have something extra there, I think. F double prime is x at negative 2. They say x is greater than 0. Okay, we're not sure how that's going to work right now. F of 1 is 0, f of 2 is 0. Okay, so what's so good about x greater than 0? Well, well, let's see. So let's see what happens. Okay, so we're at the second derivative level. Go back to the original function. F of 1 is 0, f of 2 is 0. Okay, f prime of x, first integral of x to negative 2 dx. Okay, this, we're kind of messed up in our brain now, because whenever I see f prime, right, we're used to saying, oh yeah, f prime, take a derivative. But here, we're actually taking an antiderivative because we started not at the f level, we started at the f double prime. So take one antiderivative, and you're at f prime. So I integrate x to negative 2. X to negative 1 over negative 1. Power root, right? Add 1, divide by the new exponent. And that's the same as negative 1 over x plus c1. Okay, integrate again. F of x. I messed up here. That's f of x. By the way, you might be wondering, how come I don't plug in stuff here like the previous problem? Well, the previous problem, they told us something about f prime of whatever. They don't give me that in this problem. Where'd it go? Where am I? Here. Okay, they give me 2 pieces of information up at the f level. But they don't say f prime of whatever equals blah, blah, blah. So I can't use it. So I just have to leave it alone. Okay, integrate. What's the integral of negative 1 over x? Negative ln absolute value of x. Okay. Remember, the integral of 1 over x is not just ln x. You need the bars. Ln absolute value of x. Integral of c1, c1x, plus its own constant, c2. Now this is where the next level, I'm going to write it like this, because they said at the beginning x is greater than 0. Okay, so if x is greater than 0, I can drop the bars. It's just that. Okay, now I'm at the f level. I have to use this information. Where'd it go? When I plug in 1, I get 0. And when I plug in 2, I also get 0. Okay, well, that's how it goes. So f of 1 is 0. 0 is the answer when I plug in 1 and 1. So negative ln 1 plus c1 times 1 plus c2. Okay, natural log of 1 is 0. So that means 0 is equal to c1 plus c2, or c1 is the opposite of c2. Okay, so I'll keep that in mind. Basically, I'm going to have 2 equations and 2 unknowns. Okay, so I would not have enough information to find c1 or c2 if all they gave me was this. But they gave me this too. So with this information, I can figure out both C1 and C2. So C1 and C2 are opposites. Just subtract C2. C1 equals negative C2. Now I need to plug in f of 2 equals 0. So 0 is the answer when I plug in 2 here and 2 there. And I will bring it all the way back up to here now. Okay, so 0 equals negative ln 2 plus 2C1 plus C2. Okay. All right, so I add ln 2 to both sides. 2C1 plus C2. Okay, and I decided to go back and use 0 equals C1 plus C2, so I can solve by elimination. Two equations and two unknowns, right? Natural log of 2 equals 2C1 plus C2. 0 equals C1 plus C2. So multiply the second equation by negative 1. 0 equals negative C1 minus C2. Add them up. C2 drops out. So C1 is equal to natural log of 2. And since C1 and C2 are opposites, C2 is negative ln 2. Okay, so we solved for the constants. They were a little bit awkward. So C1 is natural log of 2. C2 is negative ln 2. Take the C1 and C2, plug it back into there, ln 2, and there, negative ln 2. And then I'm done. So finally, my answer is f of x equals negative natural log of x plus x ln 2 minus ln 2. So this is one and only one function. Okay? So when they give me this extra information, it's a pretty good sign that you're not going to have your answer with a C. Okay? So you know how the first problems had plus C, right? All these had plus C, or maybe C1 and C2 and C3 for some of these. But once you see stuff like this, right? F of 4 equals 25, F of 1 is 0, you know, all this other stuff, then you're probably not going to have a plus C in your answer, because with the given information, you'll be able to figure out what the C's are. Okay, so that's what happened toward the end, it looks like. Okay. All right, I was just going to show you one more problem, 63. So we got some problems at the end, 59 and 63. So I'll show you one of those, 63. So after this problem, I'll be done with a section. So I'll be done in a few minutes. Then if anybody wants to ask questions from this section, you may. And if not, we can call it a day. Okay, so we talked about this concept before. I'm on page 357. Okay, so if you're given a distance function, you might recall the first derivative was the velocity, v, and the second derivative was the acceleration, a. Now we're just going backwards. You might start off with the acceleration. So if you integrate once, you're at the velocity level. And then if you integrate again, you're at the distance level. And yet the convention they use for distance is s. They don't want you to use d because d stands for derivative. Okay, so a particle is moving with the given data, find the position of the particle. So notice what happened before, right? Before, okay, here's the distance function. Find the velocity. Oh yeah, first derivative, right? Find the acceleration, second derivative. Now it's the other way around. Here's the velocity, or here's the acceleration. What's the original function, right? So if you start off at the acceleration level, take one integral, one antiderivative. I'm at the velocity. Integrate again, then you're at the distance function. Okay, so that's what's happening. Okay, so I'll do 63 and then I'm done. I know some of you had chat, so I'll check the chat, or maybe if Prasanna is there, you can answer those. So A of C is equal to blah, blah, blah. S of 0 is 0. S of 2 pi equals 12. So again, I'm anticipating my final answer is not going to have a plus C because I can figure out what they are. Okay, so velocity is the integral of this function, 10 sine t plus 3 cosine t dt. Okay, again, notice what happened again. Before, we said, oh yeah, velocity, first derivative. Okay, but in this case, velocity was the first antiderivative from the acceleration. Okay, integral of 10 sine of t, negative 10 cosine t. integral of 3 cosine t, 3 sine t, plus c1. And the information they give me was at the s level, the distance level, so I can't plug in anything now. So I just have to integrate this. So the distance function, s of t, is the antiderivative of the velocity function. So we're just going backwards. Before we started off with the distance, right? Then we said first derivative, velocity, second derivative, acceleration. Now we're going backwards. Here's the acceleration. So integrate, velocity, integrate again, acceleration. Okay, so the integral of negative 10 cosine t, negative 10 sine t. Integral of 3 sine t, negative 3 cosine t. Integral of c1, c1t, plus c2. Okay, how do I find c1 and c2? I plug in. S of 0 is 0, S of 2 pi is 12. Let's plug in 0, 0. Hopefully that's nice. This doesn't look as nice, but be that as it may. So S of 0 equals 0 means when I plug in 0, the answer is 0. So 0, the result is, put a 0 there, negative 10 sine 0, minus 3 cosine 0, plus C1 0, plus C2. Okay, sine of 0 is 0, that's nothing. That's nothing. But the cosine of 0 is 1, so negative 3 goes there. So that means C2 is 3. So I now know S of t is negative 10 sine t minus 3 cosine t plus C1 t plus C2, which is now 3. Now I use the fact that S of 2 pi is 12. So I plug in 2 pi there, and there, and the result is 12. So 12 is negative 10 sine of 2 pi minus 3 cosine 2 pi. And of course, because sine is periodic, when you plug in 0, you get the same thing as 2 pi for something like trig, for sine and cosine. But not so over here. Plug in 2 pi there, plus 3. Okay, so 12 is equal to sine of 2 pi is 0. Cosine of 2 pi is 1, negative 3. Very conveniently, negative 3 plus 3 cancels out that 0. And I have plus 2 pi c1. So 12 equals 2 pi c1 divided by 2 pi. C1 is 6 over pi. So plug this back in for C1, 6 over pi, and finally we're done. Okay, so this is my answer. S of t is negative 10 sine t minus 3 cosine t plus 6 over pi t plus 3. So one and only one function. 3 properties of this function. Property number 1, when you plug in 0, you get 0. I don't feel like checking this, but if you plug in 0, you get 0. Property 2, when you plug in 2 pi, you should get 12. Put 2 pi there, and there, and there, you get 12. Property number 3, the second derivative is this, 10 sine t plus 3 cosine t. Okay? All right. So that's the way that one goes. Okay, I'm done, folks. Let me check the chat. And if anybody wants to ask questions, you may. I was not planning to start 5.1. So that's that. So let me go back there. Check the chat. Okay, Jimmy got that. Okay, the next quiz. So the next quiz will be what? The usual Friday, and it'll be due Monday. So I'll give you a quiz. We're far away from the next quiz. It's only Tuesday. But yeah, I'll figure that out. Okay, and thank you, John. Thank you, Prasanna. And let's see. Okay, somebody asked for 4.945. Okay, let's see. That one. 4.945. Okay. 9:45. And does anybody else have something? Again, unfortunately, once I switch over to the sharing the screen, I can't look at the chat anymore. I'm trying to go back out. 4.945 F double prime is e to the x minus 2 sine x f of 0 is 3. F of pi over 2 equals 0. I know you can't see it yet unless you have the book. Okay, so 45, double check f double prime e to the x minus 2 sine x, f of 0 is 3, f of pi over 2 equals 0, 4.945. Okay, I think that's it. And I see nothing else in the chat right now. Okay, so we'll go with that for now. So f prime is the integral e to 2x minus 2 sine x dx. And please notice the way you're supposed to write it. Okay, once you have more than one term, if there's a plus or minus, you put it in parentheses and dx, or dt, or d theta, whatever it happened to be. Okay, what's the integral of e to the x? Yes. What's the derivative of negative 2 sine x? Sorry, integral. Integral of negative 2 sine x. Positive 2 cosine x. Is that right? How can you check? Take the derivative. Derivative e to the x is itself. Derivative of 2 cosine x is negative 2 sine x. And derivative of c1 is 0. Okay, that works. Do it again. And then I'm at the f level, right? So whereas before, right, we just started off with f. Okay, find f prime, find f double prime. Now it's backwards. Here's f double prime. What was the original f? So you integrate once to get back to f, integrate again, finally get that. So we integrate e to the x plus 2 cosine x plus c1 dx. Okay, integral of e to the x, e to the x. What's the integral of 2 cosine x? 2 sine x. Integral of c1, c1x plus c2. Double check. What's the derivative of e to the x? E to the x. What's the derivative of positive 2 sine x? Positive 2 cosine x. What's the derivative of c1x? c1. Derivative of c2 is 0. It works. Okay, and now I take advantage of this information. When I plug in 0, I get 3. When I plug in pi over 2, I get 0. Okay, so f of 0 equals 3. Means 3 is the answer when I plug in 0. So e to the 0 plus 2 sine 0 plus c1 times 0 plus c2. Okay, e to the 0 is 1. Sine of 0 is 0. 0 times that is 0 plus c2. So subtract 1. c2 is equal to 2. Okay, so I plug that back into here. So I now know f of x is, I just copied the same thing except for c2, I'm going to put 2 instead. E to the x plus 2 sine x plus c1x plus c2, which I now know to be 2. Okay, so you say, how do I find c1? Now I plug in this, and hopefully that gives it to me, right? So f of pi over 2 equals 0. So I put pi over 2 here. Oh, that doesn't look very nice at all. E to the pi over 2. Oh, well. Put a pi over 2 here, put a pi over 2 here, and hopefully I can find c1. So 0 is the answer when I plug in e to the pi over 2 plus 2 sine pi over 2 plus c1 pi over 2 plus 2. Sine of pi over 2 is 1. So that's 2. 2 plus 2 is 4. So e to the pi over 2, very awkward, plus 4 plus c1 pi over 2. See if I did that right. 2, 4. Okay, throw these over, subtract. Negative 4 minus e to the pi over 2 equals C1 times pi over 2. So multiply by 2 over pi. And that gives it to me. So C1 is equal to this weird thing, negative 8 over pi minus 2 over pi e to the pi over 2. Okay, that weird thing is my coefficient way back over here. Okay, so now all I'm going to do is copy this, except for C1, I'm going to put that, and that's about it. Okay, so my final answer, let me stick it over here. I copy this, I copy this, I copy the 2, but my C1 is going to be all this. Okay, so here we go. Final answer, e to the x plus 2 sine x plus C1x, which is now all of this. So how about I put plus negative 8 over pi minus 2 over pi e to the pi over 2. Right, that's my C1. X plus 2. And that's about it. So that should be my final answer for that one. Mistake, which is not always a good assumption. Okay. This is still recorded, so if I'm going too fast, you can always look at the video later. Okay, so let me stop the share. I think I'm caught up. Okay, anybody else want to ask a quick question? Otherwise, we're done for the day. So you should be able to do the rest of 4.9, and then tomorrow I can get started with 5.1, hopefully. Okay, so anybody else, please? Okay, we'll call it a day. All right, so that's it for today, folks. So have a good afternoon, and we'll see everybody tomorrow. Okay, bye, everybody.